This is finding a standard deviation of a frequency distribution. So it's very similar to the one we did above. Now our data is in a frequency distribution. So the actual data they're talking about there would be 1, 2, 2, 2, 2, 2, 2. There would be 6 2s is what they're saying. There would be 10 3s. Yeah, so if we list the data all out, it's just too much to do with the method above with this, because you can see the rows would be just too many. So instead, let's use this method, which says we can take into account the frequency or number of repetitions with the letter F. So if you just follow all the steps in this table, keep in mind that we do want to find the mean of this frequency distribution, which, as we saw in the past, is sigma xf over sigma f. So that's why those columns are there for f and xf, because we want to use those to find the mean of the distribution. And then we also want this formula for sample standard deviation of a frequency distribution. It'll be sigma x minus x bar squared f over n minus 1. Very similar to what we did before. So my first task is just to multiply x times f. So I'm going to do 1 times 1 there to get 1. We'll do 2 times 6 to get 12. 3 times 10 makes 30. 4 times 8 makes 32. We need to know the sum of xf. So we just want to add up this whole column here. And that's going to be 75. Then we want to find the sum of f as well. So that is 25. We'll have sum of xf over sum of f is 75 over 25, which makes 3. So our x bar is 3. And then we'll put those 3's in. Then we want to do x minus x bar. So you do 1 minus 3 to get negative 2. 2 minus 3 makes negative 1. 3 minus 3 is 0, and 4 minus 3 is positive 1. Then you want to square the values that you found. So we'll do this, and we'll get 4. We'll get 1, 0, and 1. The last step is to multiply the frequency times the square that we got there. So 1 times 4 will make 4. And then 6 times 1 makes 6. 10 times 0 makes 0. And 8 times 1 makes 8. This makes our sum of squares times f into 18 if you add this column up. And now we can just plug it in, plug it right into the sample standard deviation formula. 18, and we need n. So what is n? N is the sum of the frequencies. Yeah, it's the total number of data pieces that this distribution represents, so that's 25. So we want the square root of 18 over 25 minus 1. I get 0.866